Light reflex. Light reflex can be direct light reflex or indirect light reflex. When light is directed to one of the eye, pupil of that eye constricts and it is called as direct or pupillary light reflex. In addition, it also results in the constriction of the pupil of the opposite eye, which is called as indirect or consensual light reflex. And bilateral innervation forms the basis of indirect light reflex. If you see the pathway of the light reflex, when light falls on the retina, light is sensed and the impulses pass through the optic nerve, optic chiasma, optic tract, enter the midbrain via superior colliculus, then they enters the pretectal nucleus of both the sides. Then they goes to the Edinger Westphal nucleus of the third cranial nerve, which is a parasympathetic nerve. Then they go to the ciliary ganglion. From there, they form short ciliary nerve and they innervate sphincter pupillae of the iris, which causes the constriction of the pupil. And the effect will be the constriction of the pupil of both the sides. Accommodation reflex. Accommodation is defined as the ability of eye to focus an object at varying distances. It is a reflex action. When a person changes his gaze from distant object to near object, three adjustments are made in the eyeballs. The first one is convergence of the eyeball due to the contraction of the medial recti. The second one is constriction of the pupil due to the contraction of the constrictor pupillae of iris. And third one is increase in the anterior curvature of the lens due to the contraction of ciliary muscles. And this response is also called as near response. If you see the pathway afferents, they mainly from the visual impulses from retina pass through the optic nerve, optic chiasma, optic tract, lateral geniculate body, optic radiation to the visual cortex. From here, the association fibers carry the impulses to the frontal lobe. The center for accommodation lies in the frontal eye field, which is situated in front of the in frontal lobe area 8. Efferent pathways are to the ciliary muscles and sphincter pupillae. From area 8, the corticonuclear fibers pass via internal capsule to the Edinger Westphal nucleus of third cranial nerve. From here, preganglionic fibers pass through third cranial nerve to ciliary ganglia. The postganglionic fibers from ciliary ganglion pass via short ciliary nerves and supply the ciliary muscles and sphincter pupillae. There will also be efferents to the medial rectus. Some of the fibers from frontal eye field terminate in the somatic motor nucleus of third nerve. The fibers from motor nucleus supply the medial rectus. So when there is a visual response is seen in the eye, it passes through the optic nerve, optic chiasma, optic tract, then they enters the lateral geniculate body, optic radiation, then they goes to the visual cortex area number 17. From there it goes to the frontal eye field area. From there it goes to the Edinger Westphal nucleus of the third cranial nerve, and through ciliary ganglion, through short ciliary nerves, they leads to contraction of the ciliary muscle and increase the anterior curvature of the lens, and similarly contraction of the constrictor pupillae, they lead to the constriction of the pupil. And at the same time, there will be stimulation of the somatic motor nucleus of the third cranial nerve, which causes the contraction of the medial rectus, which leads to convergence of the eyeball. Some of the applied aspects. Argyll-Robertson pupil. In this condition, pupillary constriction in response to a light stimulus is absent or decreased, while the response to accommodation is present. Pupillary reflex pathway is dorsal to the pathway for near response. Consequently, even if the light response is lost in response to accommodation, still remains intact, and it is usually seen in midbrain region. The effect can be remembered like this, like in ARP is accommodation reflex present and PRA, that is pupillary reflex, absent.